Hey guys, Mr. Wooten here once again. We are now on problem number 6 from the Unit 1 study guide involving solving equations and inequalities. Once again, we have a problem where we are simply solving for a variable, in this case x once again. And if you look at the equation, we have negative 7x plus 6 equals 2 times the quantity x minus 4 in parentheses minus 5 times the quantity of negative 8 plus 3x all in parentheses. Again, same as what we've seen in the last few problems. There is nothing I can simplify in these parentheses here. X minus 4 can't be combined into one term. Negative 8 plus 3x cannot be combined into one term because we have x's and then we have constants, numbers without variables. Those cannot be combined into one term. So then we go into our exponents, but there are none, and then multiplication. So I do see that I have a 2. I can use the distributive property to multiply that by this x and by the minus 4. And I can also multiply this 5. Notice, and I want to kind of underline this 5 has a minus in front, so when we multiply this, we're going to be thinking about this as if it was a negative 5 times each of these numbers. Okay, so do not forget about this symbol right here. If it was a plus, we would think about it as positive 5. Since it was minus, we're going to think about it as a negative 5. So keep that in mind as we work through this. On the left-hand side, there was nothing going on as far as multiplying, other than what we already see, negative 7 times x plus 6 equals, now let's do this multiplication. 2 times x is 2x. 2 times negative 4, positive times a negative is a negative. 2 times 4 is 8. Okay. Now we get to this problem, like I was saying earlier, we're going to view this 5 as a negative 5. So negative 5 times negative 8. A negative times a negative is going to give me a positive, or plus. 5 times 8 is 40. Okay. And that should make sense because we were subtracting something that was negative. That's the same as adding a number. Even once we multiply the 5 times the 8. And then this one was added originally, adding 3x, but then we are subtracting 5 times that number, so a negative times a positive is going to actually turn that into a negative. Okay, and then 5 times 3x, 5 times 3 is 15, we had an x there, so it becomes minus 15x. Alright, so now, again, nothing I can really do on this left-hand side, but if I look at the right-hand side, I see that I have x terms I can combine, here and here. And then I'm also going to have these constant terms that I can combine here and here. So let's go ahead and combine the x's first. 2x minus 15x. 2 minus 15, that's going to put us into the negatives. That's going to give us negative 13x when I subtract. And then as I look at my constant terms, negative 8 plus 40. Again, be careful here. Imagine if we're on a number line, we're at 0, we subtract 8. So we're down here at negative 8, then we turn around and add 40. We're going to be way up here. However, it took 8 of that 40 number, took 8 of those units to get back to 0. So then what part is left over? I can almost think about this as subtracting the positive number minus the negative one, or just minus 8. So 40 minus 8 is actually going to give me 32, positive 32. Okay, that's where we would end up here on our number line if we were looking at this. All right. So I have this equation now. This is very similar to the ones from problem 4 and 5. I simply need to cancel out the x's on either side of the equation. Again, it does not matter which side you cancel out. As long as you cancel out either the x's on your left or the right, solving this equation is possible either way. So, and some people, I'll even tell you this, some people like to even cancel out just constant terms first. I personally just like to get rid of the x's first. It really does not matter. As long as you cancel something out on this first step, and you're working towards getting x's on one side and constant numbers by themselves on the other side, then you're on your way to the solution. All right? So to show you it doesn't matter, I'm just going to simply cancel out this first number right here. I want to cancel out these 7x in front. So it was a negative 7x, I'm going to add 7x to cancel that out. And since I added it on the left-hand side, I'm going to add that to the right-hand side of the equation. So those cancel. I'm left with 6 equals negative 13 plus 7. So think about that. We're at negative 13 on our number line if we start at 0. We're down here at negative 13, then we add 7x. So negative 13x plus 7x gives me a total of negative 6x. Okay? So I'm at negative 6x plus 32. Now I have x on one side of the equation. I need the constants, the numbers by themselves on the other, so I'm going to subtract 32 from both sides. 6 minus 32. Okay, so If you think about this, again, I've told you this trick before. If you ever are subtracting a number that's bigger than your positive number, then you can almost think about this as reverse. We know that 32 is bigger than 6, so we know we're going to end up with a negative number when we subtract this. So then what you can do is just simply do the bigger number minus the smaller number. So if I write over here 32 minus 6, 2 minus 6, I'm going to have to borrow 1, here comes a 2. 12 minus 6 is 6, 2 minus nothing is 2. So that means the answer here is going to be negative 26. Okay. So again, if you kind of have trouble subtracting numbers from smaller values, so if you have trouble subtracting when you end up with negative answers, this is just a little trick, something you can do to help you figure out where you're at. Now we could make sense of that looking at a number line. Here's 0, here's 6 up here. If we take away 32, well, 6 of those 32 are going to be to simply get us back to 0. Okay, so it would take 6 of this quantity right here, 6 units of that 32 units, to get us back to 0. So then what amount is left over to get us where we need to go? 32 minus 6 is 26. I just saw that. So that means we're still taking 26 away even after we've gotten back to 0. That will put us at negative 26. Okay, so that's kind of visually representing what those steps were that we were doing over here. All right. So then we did that minus 32 because that cancels that out. So we have negative 26 equals negative 6x. Last step is to divide by negative 6. Can 6 go into 26? I know it's a negative of a negative, so I'm going to get a positive answer, but 6 cannot go into 26, so we need to reduce this fraction any way we can. Can you divide, think about factors of 6, and then let's see if we can divide 26 by those. Factors of 6 include 1 and 6, and 2 and 3. We said 6 couldn't go into it. Can 3 go into it? No, it cannot. Just on a quick side note, remember there is a neat little trick for deciding if you can divide something by 3. If you add all the digits up, so in this case the number is 26, if I add the digits 2 and 6, and I get a number that I can divide by 8, then that would mean 26 can be divided, or excuse me, that I can divide by 3, then that would mean 26 could be divided by 3. So if I add 2 plus 6, that gives me 8, but right off, since that's a smaller number, it's easier for me to say no, 3 can't go into 8 in even number times. Since 3 can't go into the sum of these digits, 2 plus 6, 3 cannot go into 26. Okay, again, a neat little trick with figuring out if you can divide something by 3. But then since 26 is even, we know we can divide it by 2. So 26 divided by 2 would be 13. 6 divided by 2 would be 3. And we know we can't divide 13 by 3, so that's as simplified as that fraction can be. And leave it as an improper fraction. Do not turn any of your solutions into mixed numbers, particularly on your EOC. And as you go through math, you'll realize that usually you just like to leave things as improper fractions instead of writing them as mixed numbers. Okay, it wouldn't be wrong to write it as a mixed number, but on the end of course exam, you'll be given instructions that say leave all fractions as improper fractions. Okay, so the answer to this equation is going to come out to be x equals 13 divided by 3. All right, if you have any questions on this, again, feel free to leave a comment or send me an email or just check with me in class. If you don't have any more questions, then feel free to move on to the last problem, solving equations, which is number 7.